जगत जननी शारदे, जगत जननी शारदे, है नमन तुमको, है नमन तुमको।
हेलो हेलो हेलो, अब आ रही है? हेलो, ठीक ठीक ठीक। हेलो हेलो, आ रही है साउंड? हेलो, हाँ आप, मेरी भी आ रही है। ठीक है ठीक है ठीक है।
एक मिनट में बाहर।
हेलो, ओके। हेलो 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 हेलो, सही है ना? हेलो, हेलो हेलो हेलो, वहाँ से साउंड बढ़ा के देखो, लैपटॉप के साउंड बढ़ाओ। हेलो, करता हूँ, रुको रुको रुको। हेलो हेलो हेलो, अब आ रही है? हेलो 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 हेलो, नहीं, अरे एक बार साउंड बढ़ा के देखो लैपटॉप की। ठीक है, ठीक है दीदी। आराम से भैया। वो तो स्क्रीन वैसे खराब हो रही है, वो देखो स्क्रीन खराब हो रही है वाली। इनकी स्क्रीन में कुछ हो गया। चल गई क्या? अरे यार मैं बोर्ड हो कहता हिंदी होगी, मैं खेलेगा ये।
वैसे
बोर्ड उधर कहता हिल गई। तुम आपने कहा था
ये फ्रेम
तो किसमें लगाऊं बोर्ड जो ना हिले भाई। आगे रहे इसको और अंदर कर दे, टेप मार दो।
अरे टेप ऑफ हिल जाएगा।
वो माइक्स कहाँ के जो यहाँ पड़े
यहाँ से नहीं जाएगी यार, ये बड़ी मुसीबत है।
ये हो गया बस। जैसे ये है ना
अच्छा एक सेकंड, ओके एक मिनट मैं करती हूँ एस्केप। ठीक है, डन है।
डन। और जैसे ये ओपन होगी ना, बस एस्केप दबाना है, ये कुछ ना टेक्निक काम कहाँ से दे देते हैं? व्हाई इज दिस नॉट विजिबल? इसको निकालना जरा, दोबारा डालना इनपुट, ये कुछ टेस्टिंग नहीं किया इधर रिजल्ट इस साल ना करो ना, इस साल ग्रुप होना ही। एक मिनट हो गया, ऑफ करो एक बार, इसको ऑन करो, स्विच ऑफ एंड स्विच ऑन, दैट इज द मैजिक रेसिपी फॉर एनीथिंग। रिमोट कहाँ इसका? इसका रिमोट था ना, काम कर रहा है ना, तो थोड़ा कर।
वो तो हमने ऐसे ऑन किया था इसलिए ऑटो ले लो।
ये अपन टीवी किससे लाए हैं? वो नहीं टीवी वाला, ये टीवी वाला उसकी बात में हमारा बता है। ठीक है, अभी ऑन करो दोबारा इसको, पावर लगा दिया सर, पावर लगा दिया। रिमोट ये किसका नहीं है? ऑन कैसे किया? ऑन कैसे किया? पहले तो चल ही रहा था, क्या उल्टा नहीं रुकी आ रही है, आगे स्ट्रेट आ रही है, स्क्रीन उनको दिखेगा। एक बार हमें अभी टीवी ना, टीवी में इसका मालिक माइक्स का है, तो बार बार में तो माइक क्या पड़े, ये दो है ना सर, ये और ये भाई है, ये माइक लगा के देंगे सारे अभी थे यहाँ पे माइक पे क्या लगेंगे, इसको माइक में कीप दें, यहीं रखो ना, टेबल पे रखो, जब चाहिए होगा फिर हम लेफ्ट राइट भागेंगे। वो बोल के बैटरी सही है, आपका
कहाँ कैश दे भाई वहाँ
चल रही थी, चलते चलते उल्टी हो गई।
ये बन क्यों रहा है?
इसमें ही है।
कार्तिक वो छोड़ दो माइक।
एक मिनट रुक जाओ। स्लाइड में भी
स्लाइड बना रखे वो कहाँ से हट जाएगी?
नहीं नहीं, अगर मैंने इस स्लाइड को यहाँ से स्टॉप कर दिया, ठीक है, अब स्लाइड शेयर करनी है बस।
शेयर करनी है ना।
आपकी स्क्रीन वन शेयर होकर नहीं आ रहा है, वो ऐसे आएगा, हटने का नहीं।
क्या नहीं हटने का, ठीक तो था।
वन
पहले नहीं आ रहा था।
वन लिखा हुआ है,
ऐसे ही नहीं आएगा।
ये ना
हाँ फिर चला तो गया।
इसको मार दे।
सुन तो लो, सुनो प्रिंस भाई, अरे प्रिंस भाई,
इसीलिए मैं कह रहा था सर आप चालू करवा लो। नहीं हम चालू करेंगे, हम चालू करेंगे। लगा दो। बस बस ज़्यादा लैपटॉप हो गया सारा क्या हो गया काम हो गया यार तुम ये वाला टेप लगाते हो मास्किंग टेप नहीं है तुम्हारे पास
पहले लगाई थी पुराना आपने हमने लगाई
और तुमने कसर छोड़ी नहीं
पहले लगी थी पर मैंने
अब वो देख हिल तो नहीं रहा
पहले लगी थी
मैंने बोला मास्किंग टेप लगाना है तो हेलो टेप किसकी हेलो सर एक बार चेक कर लो अपने साथ कोई कमी लग रही है तो अभी बता
ये नेक्स्ट ही नहीं हो रहा, ये कमी है, पहले ही बता।
नेक्स्ट नहीं हो रहा ये पॉइंटर ऑन होगा तो जरूर होगा स्लाइड पे है ना
नेक्स्ट नहीं हो रहा क्योंकि इसकी नेक्स्ट स्टैंड थी
हैं?
क्योंकि इसकी नेक्स्ट स्टैंड थी ना इसलिए नहीं हो रहा था
भाई वो तो कर दूँ अब, हो रहा है अब। चल कर अब उस पर कर, नॉर्मल या पहली वाली पे 20
तब तो नॉर्मल है ना जगह देखो ना होगी
20 से नहीं चेक करते यार, पहली दूसरी भी चेक करते। 20 लाने में भी फिर 10 मिनट बर्बाद होते हैं। दे दूसरी दे अब। ये साउंड कहाँ से जा रही है बीच बीच में?
ये सर ये साउंड अब जब तुम दबाओगे ना अगला प्रेस करोगे जब जाएगी
वो नहीं मैं कह रहा,
हाँ।
यहाँ कहीं व्हाट्सएप खुला है या कुछ खुला है, किस पे आ रही है ये?
नहीं वो वैसे नॉर्मल
सर वो नॉर्मल जैसे
नहीं,
फर्स्ट लाइट है ना
WhatsApp की
अब तुम
sound
जीरो
आई थी।
व्हाट्सएप किस
हेलो
साउंड होती है सर वो तो
कोई तुम्हारे या किसी का बजा होगा फिर वो।
एक मिनट में देख दो सर रेंचो लैब का क्या क्या है एक और है उसका 3 है शायद मेरे में खुल ही नहीं रहा वो रुक जा उससे क्यों कर चेक करना सर
द सेम मेल सर
बता
क्या
क्या
है
बनाए?
डुप्लीकेट
इसके स्टैंड पी ना मैं तभी तभी वही तो वो देख रहा था उसको
तू भी कलाकार ही है
मजे मतलब लगा दे इसको फटा।
ज्वाइन करेंगे पार्टी सब
मिनिमाइज करना अब छोड़
दे आगे
चेक करना पार्टी सब ज्वाइन करना
सामने ही है।
वन पे कर वन पे मन से पहली स्लाइड पे कर
Yes, you can hear and see me.
Yes sir, we can hear you. Sir, we can hear you.
माइक
Oh
ऑन
yes sir, we
करके
can see you also.
माइक ऑन करके बोल
Yes sir.
Good. I'll switch off both mic and camera,
Fine sir.
but remain connected.
Fine sir. Fine sir. Thank you.
Okay.
Thank you, sir.
See you all at 10:30.
Thank you sir.
कॉन्ट्रैक्ट नहीं चल रहा यार
पाटिल सर का सर्जरी हुआ सर तो इस वजह से ही इज़ अलाउड टू सिट ओनली 10 minutes, upright only 10 minutes. So he will join online for that. He have to prepare be 1 महीना और कम से कम लगेगा सर टू रिकवर. It's a spine thing, so
तो ये क्यों नहीं ले रहा
वो स्लिप डिस्क वाला ही है सर.
तो बंद करना उसे ऑटो को
गुड मॉर्निंग सर. अरे सर प्लीज़ पाप मत लगाइए मुझे सर, बैठिए सर प्लीज़. नहीं ऐसी कोई बात नहीं सर. आ रही है कितनी देर में आएगा? 10 मिनट में आ जाए तो हो जाएगा काम. 15-20 हाँ ठीक है. 10:30 से पहले आ जाए तो ठीक है. इसको हटा ही दो यार, इसको ना हटा ही दो. इसको हटा देते हैं टीवी को. अच्छा नहीं ख़राब लगेगा. ठीक है हाँ ठीक है फर्स्ट क्लास है. दिस इज़ गुड फ्रेम.
सेट कर
बिल्कुल दिस इज़ परफेक्ट. ये माइक कहाँ से उठाया था यार? देखो माइक को ना अपनी जगह रख दो. फिर अभी टाइम नहीं है अब सर. अब देखो ना आप धीरे आप समझो बात को. यस ये वायर माइक किधर? सर के पास. ये सर को लगाना है आपने यहाँ पे. जैसे आएंगे लेट टू हेल्प हिम. ठीक है ऑफ कहाँ से होता है?
ऑन करना है। Hello. Hello. 1, 2, 3. Check. Hello. Hello. Mic testing. Hello. 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 Mic testing. Hello. Hello.
Ladies and gentlemen, a very good morning to all of you. I'm Imansa from Indian National Academy of Engineering, your host for 40th Foundation Day of Indian National Academy of Engineering. May we request you to please be seated and put your mobiles on the silent mode. Good morning once again. On behalf of Mr. J.D. Patil, President, Indian National Academy of Engineering, we extend a very warm welcome to our invited dignitaries, former presidents of INAE, Dr. Sanak Mishra, formerly Managing Director, Rourkela Steel Plant, Director, Steel Authority of India Limited, and Professor Indranil Manna, Vice Chancellor, Birla Institute of Technology, Mesra, former Professor, IIT Kharagpur, and Vice Presidents of INAE, Professor Santanu Chaudhary, Dean and Professor, Vashani School of Advanced Computing, Ashoka University, former Director, IIT Jodhpur, Professor Sanjay Mittal, Department of Aerospace Engineering, IIT Kanpur, Professor Shivaji Chakravarti, Professor Electrical Engineering Department, Jadavpur University, Kolkata, and former Director, NIT Calicut, Mr. Pradeep Chaturvedi, Vice President, World Environmental Foundation, New Delhi, and Dr. S. Somanath, Vikram Sarabhai, Distinguished Professor, ISRO, former Chairman, Space Commission, Chairman, ISRO, and Secretary, Department of Space, Bangalore, Mr. T. Suvarna Raju, formerly Chairman and Managing Director, Hindustan Aeronautics Limited, Bangalore, members of INA Governing Council, esteemed fellows, INA Young Associates, members of INA, research scholars, and students to 40th Foundation Day of INA. For those of our guests who may not be familiar with Indian National Academy of Engineering, I will be giving you a brief introduction. INA was established on April 20th, 1987 as a society under the Societies Registration Act 1860 and is an autonomous professional body located at Technology Bhavan, New Delhi. The Academy comprises India's most distinguished engineers, engineer scientists, and technologists representing the entire spectrum of engineering disciplines as its fellows. It functions as the apex body for promoting the practice of engineering and technology and their application to solving problems of national importance. Ladies and gentlemen, allow me to take you through a brief journey of Indian National Academy of Engineering. The seeds of INAE were sown when Professor S.N. Mitra, past president, Institution of Electronics and Telecommunication Engineers, envisioned the need of a unified national body of engineers following the concerns raised by Professor C.S. Jha, Educational Advisor, Department of Education, regarding the absence of single advisory platform for Government of India. With the dedicated efforts of Professor S.N. Mitra and Professor A. Bhattacharya, past president of IE, and their colleagues, the Academy was formally registered on 20th April 1987 under the leadership of founder president Professor Jay Krishna, formerly Vice Chancellor, University of Roorkee. A defining moment came on 11th April 1988 when INE was formally inaugurated in New Delhi by the then Prime Minister, Shri Rajiv Gandhi, in the distinguished presence of Shri P.V. Narasimha Rao, the then Minister of Human Resource Development, and Shri K.R. Narayanan, the then Minister of Science and Technology, both of whom later went to serve as the Prime Minister and President of India, respectively. We also take immense pride in remembering all the past presidents of INA. Late Professor Jay Krishna, founder president INA and Vice Chancellor, University of Roorkee. Dr. V.S. Arunachalam, former scientific advisor to the Ministry of Defense and Secretary, DRDO. Late Dr. S. Varadarajan, former Secretary, DST. Late Dr. APJ Abdul Kalam, former President of India. Late Professor P.V. Indrasen, former Director, IIT Madras. Dr. Anil Kakotkar, former Chairman, Department of Atomic Energy. Professor P. Ramarao, former Secretary, DST, and former Chairman, Atomic Energy Regulatory Board. Late Dr. A. Ramakrishnan, Board of Directors, L&T. Dr. K. Kasturi Rangan, former Chairman, Department of Space. Dr. P.S. Goyal, former Secretary, Ministry of Earth Sciences and Chairman, Earth Commission and Director, ISRO Satellite Center. Late Dr. Baldev Raj, former Director, Indira Gandhi Center for Atomic Research. Dr. B.N. Suresh, Chancellor, Indian Institute of Space Science and Technology, and Honorary Distinguished Professor, ISRO. Dr. Sanak Mishra, formerly Managing Director, Rourkela Steel Plant, Director, Steel Authority of India Limited. Professor Indraneel Manna, Vice Chancellor, Birla Institute of Technology, Mesra, former Professor, IIT Kharagpur. Their visionary leadership continues to inspire generations, and their contributions have left an indelible mark. Over the years, the Academy has introduced several landmark initiatives. In 1990s, it began organizing national and international conferences and publications and instituted prestigious recognitions such as INA Young Engineer Award in 1996 and the Lifetime Contribution Award in Engineering in 1997. It also initiated efforts to preserve engineering heritage through expert study groups. In 1999, INA became a proud member of the International Council of Academies of Engineering and Technological Sciences, strengthening its global engagement. The 2000s saw the launch of several impactful programs, including the Distinguished Visiting Professorship Scheme with All India Council of Technical Education, as well as mentoring initiatives for engineering teachers and students, INE Chair Professorship, and INE Distinguished Professorship Technology Scheme. From 2013 onwards, INE launched its flagship engineering conclave, bringing together leaders from government, academia, and industry. The Academy also introduced the Outstanding Teacher Award in 2016 and launched its research journal and INE Letters. In 2017, several forward-looking initiatives were introduced, including the INE Youth Forum, Youth Conclave, Innovator Entrepreneur Award, and the prestigious Abdul Kalam Technology Innovation National Fellowship, honoring Dr. APJ Abdul Kalam. In recent years, INE has further strengthened its role through digital transformation and strategic collaborations with national organizations such as DST, DRDO, ISRO, DAE, and CSIR. It also instituted the Woman Engineer of the Year Award in 2020, recognizing outstanding contributions of women engineers. Between 2022 and 2025, the Academy underwent a significant transition towards financial autonomy following the phased disengagement of government funding. INE has taken several steps to embark on a journey of self-sufficiency and financial autonomy. Towards this, several initiatives were launched in the year 2024, such as memberships, corporate donation, institutional membership, and individual donations and membership, the quarterly e-magazine INE Tech Frontier, the Technology Conclave, and the Center for Engineering Education Excellence CEEE program with the support of Infosys Foundation. INE honors Indian and foreign nationals who are elected as foreign fellows and fellows by peer committees in recognition of their personal achievements in engineering, which are of exceptional merit and distinctive eminence in new and developing field of technology. The Fellowship of INE is the premier gold standard, and the membership is an independent category. Today, INE stands as an autonomous apex body, driving engineering excellence, shaping national policy discourse, fostering innovation, and contributing meaningfully to the nation's development. As we celebrate this Foundation Day, we not only honor a rich legacy, but also look forward to a future driven by knowledge, innovation, and collective progress. To commence this August gathering, we shall begin with the invocation ceremony and lighting of lamp, symbolizing knowledge, wisdom, and pursuit of excellence. May I request our esteemed dignitaries, Dr. Sanak Mishra, Professor Indranil Manna, former presidents of INA, and Vice Presidents of INA, Professor Shantanu Chaudhary, Professor Sanjay Mittal, Professor Shivaji Chakrabarti, Mr. Pradeep Chaturvedi, Dr. S. Somanath, and Mr. T. Suvarna Raju to kindly come forward for the lamp lighting ceremony.
है नमन तुमको जगत जननी शारदे, जगत जननी शारदे, है नमन तुमको सकल विद्या स्वामिनी तुम, सकल विद्या स्वामिनी तुम, वेद मूरत भगवते, दिव्य वीणा कर सजंकृत, दिव्य वीणा कर सजंकृत, शुद्ध बुद्ध विचार दे, है नमन तुमको जगत जननी शारदे, जगत जननी शारदे, है नमन तुमको।
Thank you, distinguished guests. To formally open today's proceedings, it is my privilege and honor to invite Mr. J.D. Patil, President of Indian National Academy of Engineering. We are grateful to have him join us online despite a medical emergency. He also serves as a member of board of InSpace, chairman of Indian Space Association and trustee of L&T Employee Trust. Mr. Patil is the past president and founder vice president of the Society of Indian Defense Manufacturers and has held several distinguished leadership roles, including former director of L&T Semiconductor Technologies Limited, former chairman of L&T Missile Systems Limited, Larsen Toubro Limited, and former whole-time director, Defense and Smart Technologies, and the member of Executive Committee of Management in Larsen and Toubro Limited. May I now request Mr. Patil to kindly commence the proceedings.
Thank you, Mimamsa. Are you able to hear me?
Yes, sir. You are audible, sir.
Right, thank you. Must say that it's my loss entirely not being in the hall today. But of course, doctors and your health sometimes takes a toll. I'm extremely happy for two reasons today. That first, we are completing our 39 years of operations
बड़ा कर दो इसको
and our 40th birthday that we celebrate today.
बस
This is a time to truly acknowledge exceptional contributions of past leadership of INE, the past presidents, the fellows, for all that they did to reach INE to this kind of a milestone of crossing 39 years and looking forward to some great times now that we are completely independent and autonomous institution. Just completed our first year of being completely autonomous and financially independent as an organization. It is an opportunity also to salute and pay gratitude to the distinguished, very early fellows of INE, and this is essentially where we are grateful that the three of those within the first, second year fellows who were part of INE as fellowship, Mr. Paritosh Tyagi, Professor Prem Krishna, Professor A.C. Datta are in the hall while we felicitate them little later. It is the foundational work by the founding team which was what contributed to where INE has reached today. And let's remind ourselves that 1987 when INE was founded, it was thought so important for the nation that the Prime Minister of India actually launched INE a couple of months after we were founded. And this is the status INE enjoyed all through. And of course, we are also grateful that for nearly 34 years out of this period, Department of Science and Technology decided to sort of help us out in terms of providing our operating funds. I'm fortunate and grateful also to the whole fellowship and past presidents for entrusting me the opportunity to lead INE just as with the darkest of the clouds with some silver lining were visible, with enormous amount of work that Professor Manna did. My special gratitude to past presidents for time to time guidance and handholding during the existential crisis period that we faced during last 3 to 4 financial years. I'm happy to look back that we completed our first year, that we have been able to during the year reinstate each and every of those special recognition programs of INE that we were constrained because of financial reasons to pause them and stop being what INE is known for, to recognize that exceptional talent in India in engineering and also continue working to give right kind of advice to government of India in terms of where India needs to position in times to come. I must also very specifically acknowledge the mountainous, and I repeat that word, mountainous work which the past President Professor Mannar did. As those darkest of the clouds were on the horizon, right above our head, he truly thought through and founded certain amount of mechanisms by which a corpus fund was created. Must also be able to tell everyone present there that today we are little more than two-thirds of our final target for the corpus, and the balance gap in terms of where we truly operate autonomously truly came out of the CEEE program, because besides being exceptional experiment in India, not targeting just the students, but targeting the teaching staff, so that through the teachers who essentially will be able to do something different, the engineering graduates that come out of our educational institutes would be better engineers, and this is needed now that we are very clearly marching on our India being that Atmanirbhar or its self-reliant and a developed nation in another 20 years to come. This is the kind of times to, as I said, remember those few statements which all along people have talked of in the history, that the phoenix rises from the ashes, as also when the times are tough, the tough get going. I think kudos to the past leadership of INE, who essentially saw us, advised us, handheld us to see through some of this darkest of the period of INE. Must also be extremely happy that we are now out of it. As I said, most of what we do has been reinstated, and here onwards, as we find ourselves into better and better financial situation, we can now start something far bigger and far more in terms of taking this nation forward. As I mentioned, India at the rate of 100, coming up exactly 21 years down, is a period every one of us will look forward to be recognized as a fully developed nation. I think the signs of it are already there, and these signs actually will take us now to supporting India in terms of its historic times, because the history will remember what people are doing now, next 20-25 years, in terms of positioning us very differently, and at some point in time to be the second and rather the third largest. We will be much earlier, but probably the second largest economy of the world. INE has been doing enormous amount of work, and details of that I'm sure Professor Shantanu will take care of. I'll stop at this moment, once again acknowledging everybody's contribution in the past. Also that today, as we celebrate our 40th birthday, the most important few points that we will actually be touching upon is our digital journey, which Professor Ajay Chaudhary will, rather Dr. Ajay Chaudhary will give a talk on reducing or making India far more efficient, is where the multimodal and the logistics starts fitting in, as also the high-speed rail and things like that. As we are seeing, India is putting in typically 11 to 12 lakh crores every year into infrastructure, and all this is to make India far more efficient. Cost of transportation and logistics today is a sizable part of what we transfer within India as well as export. And the target, obviously, with all these major developments, is to cut it down. We need to do it sustainably, and Professor Prem Krishna himself, led by he himself is leading exceptional professionals to take us out of it in terms of advising the government on our sustainable initiatives. What is extremely important at this juncture, also before I close, is that we spend enormous amount of efforts and energies on critical materials and critical minerals. And there's a lot which is happening, which I'm sure will get touched upon. Besides, of course, the certain amount of new relationships that we're striking off and getting into in terms of growth and sustained kind of a future for INE in doing what it does best, to sort of do it for the sake of engineering professionals, as well as support Government of India in future decision making. Thank you very much. Please excuse me not being able to be physically present. Just underwent a major surgery less than a week back. Thank you so much. Bye. Jai Hind.
Thank you, sir. We are grateful to you that you have joined us despite having a medical emergency. Thank you so much, sir. Ladies and gentlemen, we shall now proceed to the panel discussion on Engineering India's multimodal future, synergizing high-speed rail, space infrastructure, and industrial logistics for a Viksit Bharat. The panel discussion shall be steered by Professor Indraneel Manna, former President INA, and the program moderator of the discussion. Professor Manna, the Vice Chancellor of BIT Mesra, an academic with 4-decade-long career span and an active proponent of translational research in engineering, is deeply involved in several national and international initiatives on engineering, education, and technology mission, serves as a member of several national academies and policy-making initiatives, and chair multiple review and monitoring committees on engineering sciences. He is Vice President of Indian National Science Academy, INSA, and the immediate past President and Vice President of Indian National Academy of Engineering. Recently, he played a pivotal role in making INA both financially and functionally autonomous. May I now request Professor Indraneel Manna and esteemed panelists of this session to kindly come on the stage. The panelists of the panel discussion are Mr. K. Senthilnathan, Executive Vice President and Head Technical Services, Heavy Civil Infra IC L&T, Srimati Nigar Shahji, Outstanding Scientist, URSC ISRO, Professor Prem Vrat, FNAE Chairperson, Board of Governors, IIT ISM Dhanbad, and Pro-Chancellor, the North Cap University. I'm sure the audience would be eager to listen very keenly on this contemporary topic.
Friends, very good morning, and this is really a very important occasion, 40th anniversary of INE. So first of all, happy birthday to INE. 40th by some convention is called the Ruby anniversary. So happy Ruby anniversary to INE. We just heard a little commentary on INE's journey. We all are very proud that INE is today not only functionally autonomous but also financially autonomous. And it took us enormous amount of collective efforts from rank and file, from everybody. And actually Mr. Patil was exaggerating, so it was purely a team effort. By the way, we are very much missing you, Mr. Patil, and we wish you a very speedy recovery. Now, this morning, next 1 hour or so, we would like to devote to the principal theme as the session reads, the title of the session reads, Engineering India's Multimodal Future. So obviously progress and development cannot be a unilateral or like a linear motion. Synergizing various aspects of infrastructure and growth parameters, ultimately aiming to achieve what our Honorable Prime Minister very aptly conveys, that India by 2047 should emerge as Viksit Bharat or developed nation. If you look around, and no matter what you use, various AI tools and so on, there is no clear definition as to what makes a nation developed. What exactly is the threshold? So I did some homework and figured out that generally you expect the Human Development Index of a nation should be above 0.8 out of 1. And apart from, of course, the solvency part, the economic growth, infrastructure, health, education, and various other parameters. The question is that if we look around and understand where we are, I mean, let's not delve into the past and bask in the pristine glory that India until the early 18th century used to be one of the wealthiest nations, not only a knowledge capital, but even in terms of wealth, one of the wealthiest nations, contributing nearly 25% of the world GDP from one single nation. But that's distant past. But a nation which is today not only the most populous, the largest population, but also the youngest population. So it's very legitimate what the Honorable Prime Minister says, that the young population of the country would like to see themselves as members of a very eminent and a very strong member of the world community. So what are the challenges? Obviously, one would think of energy, infrastructure, transportation, security, both civil and physical and cyber, climate, and various other things. Almost all of these challenges are related to ultimately engineering, because you know the fundamentals, but when you actually find a solution, when you design and achieve a solution, you need engineering intervention. So we are very fortunate today to have three eminent professionals from engineering profession today present and willing to discuss with us very specific agenda. So we have only one lady in the panel, so I would like to first introduce her. And actually, normally I avoid reading line by line, but I just read her short resume and I thought it would be appropriate I read that little description. So Mrs. Nigar Shaji is a former Associate Director, projects responsible for steering all the ISRO developed spacecrafts, having over 35 years of experience in space mission, satellite development, and project leadership. She was Program Director, Low Earth Orbit and Planetary Missions, is responsible for the development of all the ISRO developed low Earth orbiting spacecrafts and interplanetary missions. Noteworthy contributions was steering the successful landing of Chandrayaan-3 mission. It's just a sheer coincidence that the then captain of the team is very much part of the audience and also the leadership of INAE today, Dr. Somnath, sitting in the front row. Shaji was project director for the prestigious Aditya L1 spacecraft, the first Indian space solar observatory at Sun-Earth Lagrangian point for solar studies. The notable responsibilities held as study director for mission to Venus and EXO World Mission for the study of planets beyond the solar system. So Dr. Shaji, we all are extremely proud. I mean, what we are proud, and there are reasons to be proud for one single reason. Normally in India, we always end up doing a catching up job. Some things happen somewhere, some development already established, and we prove ourselves that we too can do that. For example, we are the 8th nuclear energy harnessing nation. It took enormous, at that point of time India was the 5th. But here, by landing on the southern hemisphere of moon, we were the first. And that certainly gave the country enormous boost and pride and confidence that yes, we can do something. So why not we begin hearing from you, and maybe you can articulate what Dr. Somnath would have added, what it felt, what confidence does it give to the nation that we too can do something for the first, we can be really the pioneer. So what it takes for such a success coming from a team effort, not an individual effort, and what role engineering plays there.
Hello. First of all, thank you for the opportunity to be here with all these eminent people on the dais and off the dais, and also I'm really honored to be talking in front of my former chairman, Dr. S. Somnath, and it's really a honor for me. Actually, as soon as he came, I was telling, actually he should have been in this place rather than me, but he's the correct person. And also when because you were talking about Chandrayaan 3 landing, and the captain is sitting in front of me. But actually, it, as you said, no, this entirely boosted the confidence of the nation, especially the younger generation. So everyone was because if you see, it was that. Compared to any other or a movie launch or a cricket match victory, the day of the landing, the people who were witnessing was far, far greater than all these crowds who were watching the cricket matches too. So that was the great, the confidence what we can inculcate, and the scientific temperament what we can inculcate in the younger generation was, we are really as a team, because as you told, it's not a single person's achievement or anything. It's a huge team. It is a team of the entire ISRO which made it possible that landing, and we are really proud that we could inculcate scientific temperament and confidence in the younger generation of the nation. In turn, that boost the entire confidence, because the confidence which I feel what was lacking in our country's self-sufficiency or a developed nation is the confidence, because we always feel that as a country whether we will be able to achieve something greater than what US does or what Europe does. So this is one of the incident which gave us confidence that we can also do it, and that in turn will spill over into the other engineering aspects also. So that way we feel we proud that we have given that we could do something for the nation, which is very important, the self-confidence of the nation.
So at this point, let me raise an issue that, all of us believe that unlike in science where the solution of an equation could be unique, in engineering the solutions are rarely unique. So when you design a launch vehicle, or when you design a satellite, or when you make a mission to land on the southern hemisphere of the moon, to arrive at the correct decision, I'm sure there must have been enormous amount of journey. And you already mentioned, and we all celebrate the teamwork spirit of ISRO. The question is, how did ISRO really reach to that level? Don't look at Dr. Somnath. Tell us, as a member of the ISRO family, how you felt that what should be the contributions coming from an individual. Everybody has to be self-driven and be very committed to make that contribution, which was crucial. So how can we learn from ISRO and make this habit of teamwork in the entire nation?
Yeah, it's first and foremost this, we call it ISRO culture, what you have described as the teamwork, what we do. It's the entire credit should go to our founder, chairman and founder members like Dr. Vikram Sarabhai, Dr. Satish Dhawan. So they have just built in a culture in ISRO that is it is one is the self motivation, and so as a, because we call it in IITs and the academic institute also, we call it as a peer pressure, right? So the same thing plays. It's not like a working atmosphere, it's like a learning atmosphere, and we all be like students who has a peer pressure of doing things effectively. So that also brings in one, it's my perspective, it's a teamwork which is more effective. And also that from the beginning that self-motivation was brought in every one of the person who is joining ISRO. And also the transparency, that is one another aspect. That is, even every junior who has joined ISRO very recently also will be given an opportunity to put forth his ideas, to give his comments on the design, on the, and the reviews. If you see, it's transparent, it's open, people can speak and people can put forth their ideas. So I think this is that whatever the, we grew up like an institute, not as a work center like. So that is the thing, and the self-motivation and the transparency which brings in all this team effort to a fruitful outcome.
So I think this is a very key element you mentioned, that no matter what your designation is, irrespective of your level, if you have a bright idea, you have the authority to speak out or propose, and then eventually leadership decides. So sort of trying to harness the benefits from every single level, not just a top dictated mission that from the top someone says we have to do exactly this and nothing like that. In fact, I am fortunate to be part of at least watching some of the ISRO proceedings, and I've seen not only the younger ones, the ones who have retired, who are no longer officially part of ISRO. They raise very stringent questions in your review meetings. And so that culture, what you said, is ISRO culture, is really to be learned from. ISRO is also celebrated for another reason, that here is a strategic department which also is earning or raising a huge revenue for the country. And it's not just scientific mission anymore, it is also something which is truly technological and bringing revenue. But anyway, we'll hear more from you, but for the sake of the audience, for the benefit of the audience, I think we must take note of what we heard just now about the so-called ISRO culture, where everybody feels obliged to contribute and every single contribution is respected. So let me move to another aspect. You know, India is a developing nation, and we all would agree that for decades ahead of us, or at least 2 more decades until 2047, we have to build enormous amount of infrastructure and civil infrastructure, if not anything else. Roads, buildings, bridges, stadia, shopping malls, various amenities. Habitat, both low cost as well as very sophisticated modern ones. So we are fortunate to have a very senior leader from L&T, Dr. K. Senthil Nathan. He's fellow of Institute of Structural Engineering, Chartered Structural Engineer, Executive Vice President, Head Technical Services, Heavy Civil Infrastructure of L&T Construction, based in Chennai. So he has over 38 years of experience in design, construction, engineering, planning of large-scale mega infrastructure projects, both in India and abroad. He has led successfully many multidisciplinary engineering teams, achieving major landmark infrastructure projects. He has excellent knowledge and experience and deep expertise in structural design, construction technologies, specialized construction machineries, particularly for bridges, precast hollow piles, base isolators in buildings, extra doors, bridge, and many other technical terms. I think persons like Vasant Matsagar and Dr. Sahu, they appreciate it better. But the fact remains that India needs to build much more where we are today. So, Dr. Senthil Nathan, from your long experience, you know, the reality is that civil engineering is no longer fancied by the young community. Very unfortunate. the first department that gets filled up, everyone knows what we are talking about. No problem with those. But why is it that we are not able to attract good talent in civil engineering? And I believe that's very important. What is your take? What is the role of civil engineering, not just structural engineering, transportation, environmental, hydrology? So for making India a developed nation, what should be the role of civil engineering?
Thank you for the introduction, sir. I am not doctor at all. Thank you for giving me that honor as calling me a doctor today. And I am very happy to be here as an invitee from INAE and privileged to be among the distinguished professionals in this dais. Yes, you touched the main issue of a construction company or a consulting company of civil engineering. We need civil engineers, but unfortunately, the civil engineering is tough job that people have to realize that whatever we do, unless we put our effort, and then only it will come a reality. Why the civil engineering is not getting attracted? As I said, it's not easy profession. The younger generation, or the generation what we call Gen Z and other people, wanted to be a comfort and they want to work in an air-conditioned environment. And though we are growing, construction companies are growing at a rate of 8 to 10% year on year, but we are not stopping or we are not scared of these issues. So what we are trying to do, attract diploma holders and guide them or mold them to take higher responsibility. And where we need the postgraduates or graduates, we select them and put a training path by which they can also grow in the ladder. Not only that, we are trying to do a lot of automation, though the last 30, 40 years, a lot of mechanization has happened in the construction. So the tough job, what initially the laborers were doing, now it has been being done by most of the machineries. Now, mechanization is not sufficient because to operate machines, we need people. So we are trying to go into automation and robotics and other things. So going forward, I think the civil engineering may be a good, attractive profession. You can see a lot of robots working in construction field, and we are not going to have people for doing the work. Similarly, for supervision also. Now, the major work of an engineer is the supervision. So we'll have some artificial intelligence sort of things that it can check the quality or ensure the quality before it being done. So this is the way what a construction company like L&T is looking at. And if, for the example, what we did in the high-speed rail, we took the major part of it, the first package. We had used a drone survey or LiDAR survey as a digital form of it. And we did the mapping, everything. And we did everything on a BIM platform, and by which we could engage a mediocre engineer to supervise, because we can tell how it can be built, how it can be done, because there are a lot of digital tools like 4D and 4D, 3D to 4D. If you you can put your schedule into it, and you can teach them what are things to be done, how it's to be done. And we have some of the digital tools by which we can check the quality, or we can ensure that they are doing the proper job. So these are the initiatives what we have taken. This is definitely required for India to move forward, because we need to do more of infrastructure jobs, and especially the bridges and other things are very, very critical. We cannot make a mistake in construction, though the designs can be done sitting in an AC office, the air-conditioned office, but the work has to be done in field, and the environment conditions in India, across India, is different. So we are trying to overcome. We'll show the young engineers the civil engineering is being transformed, and after 5-6 years it will be totally a transformed profession, sir.
You know, whenever it comes to construction projects, there are three things which everybody worries about: the cost, quality, and time frame. Now, in terms of time frame, I've seen in my own eyes a 4-story building propped up just in a span of less than a month, maybe 3 weeks or so in Japan. And I'm told that in India also this is happening, I don't know, possibly happening. Now, for that you need not just precast structures, but now people also talk about additive manufacturing or some other recent innovations which can very significantly speed up and can also make things more customized. Do you think that's quite happening in India? I'm told L&T does construction at a great speed. The speed at which a highway is constructed in India, the speed at which a multi-story building comes up, they're not really, without compromising the quality. Don't you think that there is a lot that we need to achieve in this respect?
Yes, to greater extent, to avoid the site activities, we are going in for precast or prefabricated structures. Not only the civil structures, even the services also, we started doing modularization, and we go and erect at site. Here, in Mumbai, some of the residential building we have completed every floor in about 2 days' time. Whereas other places, people are telling every floor can be constructed in 1 day. We'll look in for. But there are a lot of improvements or materials are being developed. The ultra high performance concrete. Normally in the concrete grade we talk about M50, M60. Nowadays we are talking about grade up to 160 or 170, by which the sizes can be optimized. So by which the handling strength number, the concrete strength, what you're talking. Yeah, it's megapascal or Newton per mm square what I'm talking. So which we can optimize on the sizes, so the size can be optimized. Moreover, when you look at the housing, the individual likes to have his own way of housing. We are not into a standardized shape, size and other things. So going forward, yes, this also the people will change because time is money, so they'll also come to a standardized material and other things. Infrastructure development, the high-speed rail, for an example, majority is being done by prefabricated. Even normally a metro, we normally do each span small segments and erect it. But here, because of the speed, to ensure quality at this thing, we have done it the full span of 40 meter, weighing about more than 1,000 tons. And we have developed, L&T has developed the tools and tackles to manufacture them, erect them, and place on position. The main concern everybody has, the quality of construction. The quality depends on the material what we use, how we mix, and what sort of quality assurance plans what we have. So if you have a control system like a automated batching plant to produce a concrete, you will definitely ensure the quality. And if you are able to do it in a controlled environment, that means one location you do all the manufacturing of fabrication, then you can ensure the proper quality instead of going and doing various places like in situ construction. So these are the things what we are looking at, modularization and prefabrication. We are also looking for new materials, what it can be used in the construction field. Not only cement, whether some other metals can be used also, we are looking at, sir.
Civil engineering is one of the rare branches of engineering where a professional engineer is very much respected and is desired. I think you yourself is having such professional engineering recognition, right? How important that is? I mean, I don't think not even 10% of the civil engineering professionals in the country are actually accredited as professional engineers. Is that very important?
Yes, it's very important. I think when you go for overseas job, or when you want to do a job in overseas on civil engineering, they give weightage for such professional recognition. Like some of the Institute of Structural Engineering, if you want to become a member, it's not so easy. You have to undergo some exams and other things. There's an exam. If you want to become a chartered engineer, you have to undergo 7 hours exam. So you will be questioned on your basic civil engineering and what knowledge you have. So when you have such recognition or institution which is gives, when you show to other people or the client knows that you are really a professional civil engineer. So I think India also will become in due course of time such recognition. Of course, the Engineers Institute is there. They should also giving for the experience, and based on their whatever work they have done, they give the membership. So this can be broadened like international recognitions, like they should undergo some exams and interviews, then they can be made as a professional engineer.
Yeah, so we'll come back to you again, Mr. Satyanathan. Conrad, you want to say something?
He's an expert on the high-speed rail also, sir. High-speed rail.
Yeah. So, in fact, yeah, that's a good clue. We also have former Chairman Sale sitting in the audience here. Mr. Satyanathan is an expert in high-speed rail. So, what is the key for India to be, I mean, as competitive as Japan or France or China, to have really high-speed rail working in the country of that level, of 250 above kilometers an hour? So what kind of infrastructural development is required?
See, this package what we are doing between Mumbai and Ahmedabad, the design was done by Japanese, and we are only in the executor. Only the foundation part was asked to design by the contractor, and which we did. Other than that, like when metros came also initially, the international consultant provided the design. After that, the Indian consultant made the design and do it. So on the construction part, yes, there are some limitations because it all depends on the rolling stock, what sort of speed you have to run and what sort of vibration or deflection. So these are the criteria when they give the rolling stock. Definitely civil part or structural part can be designed.
But what about the design part? Was it entirely the Japanese design, or we ourselves now, having done it once in one stretch, can we now replicate that all over the country?
The yes and no, because what sort of rolling stock they are going to run, because the Japanese, whatever we are going to run here is going to be the Japanese rolling stock, which is
This
designed.
came from within the country, or was it
Which steel, sir?
the rails?
Rails, this was imported rails. And now, you know, the government has taken this thing to develop the rolling stock itself. The B280 or 280 kilometers per speed, which can run locomotive with BML is doing. So with that, when they develop the rail rolling stock, along with that, maybe what sort of rail we have to put, because the maintenance of the rail is a criteria. So if they can come out with the rail material and other things, it can be, I think India can develop all these things in due course of time. That's what I'm telling. If rolling stock, once it comes from Japan and we can see what it is and how it can be modified to Indian condition, and people like BML can develop rolling stock, then definitely other things can be done with so many industries in India. So it is not a difficult task. Like metros now, every city has a metro, and most of the metro coaches are being manufactured in India. So this also will come maybe after 5 years or 10 years, this will become. Because next phase, they are planning to put almost about 4,000 kilometers for about 7 lines. So in that, at least 1 or 2 lines, hopefully it will be a fully Indian make. Trains and other things will be there.
Yeah, I think this is where we have so much of engineering involved. The tribology is very different than when the rail moves at 100 kilometers and when it moves at 250 kilometers. Maybe Mr. Singh, you would like to make a comment, not now, but I'll come to you. So now let me turn to my right. We have one of the very senior and a very distinguished member of the engineering fraternity in the country. truly a veteran. I mean, of course, I'm not going to read out all his biodata that will consume considerable amount of time. Everybody knows Professor Prem Bharat. He's currently the Chairman Board of Governors of IIT ISM Dhanbad. Also was formerly Director of IIT Roorkee. He's also the Chairman POG of IIIT Kalyani, Pro-Chancellor and Professor of Eminence and Chief Mentor of the North Cap University, Gurugram, Honorary Professor at IIT Delhi. He's a thorough IIT product, IIT Kharagpur, IIT Delhi, and spent almost all his life. But just like me, he decided to step out of the IIT circle and now has been a part of a private university for the last 15 years. He also was the founding director of IIT Roorkee, director officiating IIT Delhi, and so on and so forth. That is long. But to his credit, he has guided more than 50 PhD theses, has been in the profession for nearly 60 years now, and 65, a lot of projects, theses, and so on. Over 500 publications. So, Professor Prem Bharat, you would like to, before you go there, I suppose you are going to make a presentation.
I actually had thought that way, since I didn't know the way of, I made PowerPoint presentations, but given the kind of,
I think it's
I would like
discussion.
I'd like to skip that PPT and would like to fall in line with what you.
So then I would like to,
absolutely.
I'd like to pose a very important question that the nation is very keen to achieve. Excellence and higher level of competence in manufacturing. This is where again, from Niti Aayog to the Prime Minister and so on, we always aspire to reach 30% of the GDP coming from manufacturing. Right now, it may be an issue of debate. Some people claim that it's 15%, some claim it's 80% and so on. But certainly not to the extent where we can compare ourselves with the Republic of Korea or the likes of China and Japan and several other nations. But India was very, very eminent in terms of manufacturing, particularly not necessarily. So post-industrial revolution, India's record in manufacturing started declining. But we as a nation cannot continue forever to depend more than 50% of the revenue, 50% of the GDP coming from the circuit branches. Nothing against circuit branches, but only from IT and services, finance, 51% of the GDP coming is not a good news forever. So we need to change the culture, change our approach, maybe even education system, so that the manufacturing takes a driving role. And with your huge expertise, what prescription would you go by?
Actually, the manufacturing and logistics, the theme that I was given, for which I had made PPTs, these are critical engines for taking India to that Viksit Bharat, whatever you call it, by 2020. But I wish to point out the dimensions. Actually, our Honorable Session Chairman mentioned he doesn't know the parameters clearly defined as Viksit Bharat. One of the parameters that, economic parameters, is that in order to be a developed nation, we need to be a $30 trillion economy, dollars. Today we are $4 trillion economy. So therefore you can see the gap. Now this gap cannot be filled in purely by the transient service sector. And unfortunately the entire development profile has taken a totally different route. We have more than 65% of our GDP coming from service sector. And manufacturing contributes to nearly 15% today. Although I must mention that in 2011, India evolved what was known as National Manufacturing Policy. This was done under the chairmanship of Dr. V. Krishnamurthy, who was the chairman of Maruti and was the former chairman of Board of Governors of IIT Delhi. By virtue of that, I had an opportunity to, at that time it was visualized that by 2022, I'm telling you the way I missed the bus, but 2022, 25% of Indian GDP must come from manufacturing. And at that time it was 16.5. in 2011. Today it has gone down to 14.5 or something. And it was to be by 2025, 100 million jobs were to be created. And manufacturing used, so where have we slipped? There are many lessons we can learn why it happened. We made a policy without a financial backing for that. And therefore, as a result, in national manufacturing policy miserably failed because it was looked into purely in an isolated pockets of national manufacturing zones without any budgetary support, and therefore problem became where manufacturing was perceived to be not a very important attractive career option. For example, many engineering institutions, including IITs, have downplayed the role of manufacturing and production engineering. I remember there was a time when manufacturing and production engineering in IIT Kharagpur used to be one of the top sought out profession. So therefore, even engineering institutions and private sector in engineering education have miserably let us down by only focusing on cash crop, computer science and all its variants, and hardly any institution. So unless you understand that, if you really want to have a 30 trillion economy, there is no way other than revise your policies on wealth generating policies rather than wealth distributing. A service sector only does wealth management. It doesn't create wealth. Only manufacturing, and it's a very paradoxical thing, manufacturing, agriculture, and maybe intellectual wealth through R&D. These are the only three sectors which generate wealth. And unfortunately, our focus in terms of budgetary support and focus in all the three sectors is very, very, is a cause for concern. We have therefore not focused on what we require is first and foremost a focus that you really want to achieve. Otherwise, as national manufacturing policy failed literally from 16.5%, then it is now 14.5, which is supposed to be 25%.
There are claims, actually this is where we also get a little confused. There are claims in published literature and authenticated websites that the current level of India's contribution to GDP is over 18%. Now the question is not 15 or 18, the question is 30%.
Yeah, true. Actually, it was to be 25% in 2022. We are in 26. By now, it should have already been nearing 30%, because I believe that unless we focus on wealth generation, and as I mentioned, manufacturing does, in the only sector where you generate wealth. Agriculture, of course, is part, and therefore, how do we do it? First, we need to recognize that this slogan of being a developed nation by 2047 would almost meet the same fate as national manufacturing policy, where instead of 25% in 22, we are 14.5% or what, even if you take 18%. So what we need to do, look at the prioritization of our investment in even in education. There is a tremendous shortage of skill sets in manufacturing engineering. The manufacturing processes themselves have undergone a sea change. The conventional manufacturing technologies are almost getting outdated. The private engineering institutions are unwilling to invest in the latest manufacturing processes.
But Professor Premdat, imagine I'm a 20-year-old looking for a job. If the service sector offers me a fabulous salary, and compared to that, a conventional manufacturing unit offers me 1/10 of that, why would I be interested or be obliged to join?
Yeah, first you need to make manufacturing as a respectable profession. Many times people don't go for manufacturing, not because of money alone, but because it actually is a difficult job to be on shop floor, to be, and therefore remaining in an air-conditioned room and a software engineer. So it's not money alone, it's a mindset. But unless you give respect to this profession, that really people who need to generate wealth need to be respected, instead of those who manage or distribute it. And secondly, even in manufacturing sector, our focus had been in the past remained on volume rather than value. We actually, in fact, many of the manufacturing industries, they'll borrow the design from outside world, borrow the technology, and might be only doing the value addition work by way of assembly and other things. Unless we conceive, design, manufacture and supply in a total systems framework, it's impossible to offer the value for money globally.
But there's a very major push today towards entrepreneurship.
Yeah.
I think we keep hearing, you better be a job giver than a job seeker. And we do see there's a national level push towards entrepreneurship by your various missions, various projects
True.
and so on. Why is it not really making the manufacturing sector more competitive?
Actually, the manufacturing sector, even in the entrepreneurship, many of these, if you look at they're not in the manufacturing related sectors.
More on services.
They're more on sector, more on IT specific, IT driven. So we have gone for convenience rather than what is actually required as a national priority. And that's what I'm saying, that if you really want it to be a developed nation, unless we almost emulate what China has done. We put entire focus on service sector, which is very fragile. In fact, certainly you might know that we have been talking for years together that we are the 4th largest economy in the world. Last 2 days it has been slipped to 6th level because of the dollar decline, rupee decline. So if you only invest in the service sector, which is highly fragile, the real sustainable development comes only when you respect the wealth generation over wealth distribution. And this one, agriculture as well as manufacturing, while entrepreneurship being talked about, but whether it's focused in hardcore manufacturing in the emerging sector, although I must confess, in recent times, the initiative taken on sector-specific areas like semiconductor mission, in automobile sector, India has done very well, except that we need to only not add at assembling level, but create design, because the real IPR comes from your internal, and much of the money goes back to people who created the design.
I think that's a very key point you mentioned, President, that on one hand, we are so much concerned that manufacturing is not receiving the amount of attention and boost that it deserves. On the other hand, we are the 4th largest producer of automobiles in the entire world.
It's true. Yeah, that's true, and that's in volume terms. But if you look at the value added by, because if you look at the value added, because many times these are foreign manufacturers, even in Maruti, 30% components are still mandated to come from Japan. They are not permitted 100% indigenization. So what I'm saying, that the major manufacturing focus need to shift from simply value adding by way of assembling, or unless the design, IPR, which indeed takes a major chunk of the profits. We are still, in fact, we might be making cars here, but the major chunk of the profit must be going abroad. And therefore not really generating wealth for the nation. So even manufacturing needs to look at it as a holistic framework, conceive the idea, design so that you retain the IPR, manufacture at the quality by give value. How does value come? Quality at a minimal cost. So elimination of wastages of various types through efficient manufacturing processes, and optimal supply and optimization of logistics and supply chain. That's another area. So we have to look at manufacturing and logistics together rather than only focusing on logistics. In recent times, in 2022, country did develop a policy called NLP, National Logistics Policy. And I'm happy that on that count, we are doing very well, which we're doing about 16.5% of our GDP was spent in logistics cost. In any developed nation, this figure is about 6 to 7%. By a conscious focus on developing expressways, highways, etc., we are trying to bring in those costs, and right now I believe, I'm told that it's about 11%, but unless we make it at competitive globally, unless local products become globally competitive, this can only offer if you offer value for money. That means all the hidden costs, delays, inventories and inefficiencies have to be knocked out, and unfortunately we require first the willpower to do so, the clear priorities at the national level to focus on wealth generation, and then provide all the budgetary support and the support to the educational institutions to make teaching, learning and research in manufacturing as a respectable profession, which indeed needs to be done.
You mentioned about very important sectors, but let me pose another question here. Why are we not talking about defense as a major sector which can boost economy?
True.
The wealthiest nation on earth became wealthiest not because of all the innovations, but primarily because of their control over the defense industry.
Yeah, true. I agree.
For the entire world. Why are we not really making that happen in this country?
Actually, that's a very, very, very powerful point. In fact, defense manufacturing itself is a very, very, can be very promising area. But again, we have not been focusing on even, for example, the research and design by DRDO are so sluggish in terms of getting converted into a usable product, and somewhere the fancy of our decision makers to buy only imported defense equipment, at least in the past, used to happen. So to me, defense production can be extremely vital sector. To me, it's a part of manufacturing, except that we are manufacturing for a given sector. So therefore, sector-specific manufacturing needs to be looked at in its totality, and for that we require skills, and for which unfortunately there is a tremendous skewed distribution of the trained manpower in manufacturing, in hardcore manufacturing, so much so that even when people study in computer science, when I studied in IIT Kharagpur, we had almost a very broad understanding. Each one of us, irrespective of the branch, studied some manufacturing processes, some design, some surveying, some this, some metallurgy. Today it's so that even computer science, just the knockout manufacturing, you don't require it unless, I mean, as if you don't need to manufacture computers. So we have underplayed the role, and unless we look at it from that passion, I believe that perhaps this slogan would meet the same fate as the National Manufacturing Policy 2022.
Well, I think it's time now we should take comments, queries, anything from the audience, and that's how I probably we can make the best use of the presence of all the eminent panelists here. So maybe just to make it happen, I would first ask Mr. P.K. Singh, for the benefit of the audience, he's a former chairman, Steel Authority of India Limited, and has a very checkered background. So, Mr. Singh, we just heard the need for high strength, high formable steel, not just for the high-speed train, railway tracks, but for many other applications, including defense applications. When I was an undergraduate student, we used to hear that India should produce 300 million tons of steel. Even today, we are at about 1/3 of that, 125 million tons, or maybe somewhere I read even 150 million tons. Whatever it is, the point is that we are nowhere to the target that we set many, many years ago. That's about the volume. The other part is the quality. So you led the biggest steel manufacturing sector in the country. What really is the reason? How we can bridge?
Thank you, Dr. Manna. It's a very, very broad subject. I'll tell you briefly about, I've heard all the panelists, and I completely agree with Professor Prembrath also. Manufacturing as a whole in the country, concept-wise, it's the seriousness which is required, the way China has turned around that country and the way China is still doing, where almost 25 to 30% of the GDP comes from the manufacturing. We are somewhere around, we can always debate that it is 14%, 18%, but you're decimal. For example, I was involved in the high-speed rail and all that, whatever SAIL has been doing. And we made tremendous effort of, many grades of steel which we were importing, and we did it. The INS Vikrant, where the aircraft carrier, the particular steel, but Russia has refused. We developed that steel, And we started supplying without any help from that country. The type of commitment which is required, there is no dearth of talent. The push which is required from the government, the push within the organization, that we are lacking. And somewhere, at the back of our mind, we are more interested for the imports. Because that is a much easier route. I mean, all the sweating which is required for developing a particular steel, pushing it in the market, convincing all agencies where the entire country is fancied about towards the import. So coming to the basic point, for example, the high speed rail, we can manufacture. We can manufacture, and the most important thing which is required is the length of that rail. We are doing it 160, 65 meter length. Bhilai Steel plant is producing. I mean, with little bit of, and the components which are required for manufacturing the engines and the coaches, that we are developing, but it requires cost. It is a huge cost, and you require the entire infrastructure. Once you invest that, I mean, there has to be a long-term commitment also that this money, because the payment period is very long. Unfortunately, there a lot of lackings are there. When we have developed all these steels, then this sector was open for everybody. I mean, today we are in a position to supply more rails, but we are not getting the orders. So these are some of the things which requires. Yeah.
Yeah, it's absolutely needed, and steel is the driver. There was a time when a country's progress would be measured by the amount and quality of steel produced. Anyway, so we need to really take a very serious look at that. So now we don't have much time left, so I would like to throw it open to the audience if they wish to raise any specific question or query or comments to any of the panelists. Yeah, over there. Please introduce yourself and then raise it.
I am Professor Suresh Valla, Civil Engineering Department, IIT Delhi. So my question is Mr. Senthilnathan. So we are undergoing very huge development of civil infrastructure, but now at this rate, we are not investing that much on the maintenance part. Our bridges, they are not able to sustain the design life, and this is the common observation. So why are we not investing on the modern technologies involving sensors, IoT, digital twins, so that we do a predictive maintenance rather than just following the run to failure mode, which is at the present?
Yes, now we started doing structural health monitoring. Some of the projects, important projects, are being monitored structurally, so it can give the health of the structure, and we can do for predictive maintenance. So this is, now it is coming, and we were having some technology by which at civil engineering we can embed some of the instruments inside the concrete or whatever it is, how it behaves and other things. So this is catching up now, and maybe the new infrastructure projects, it will be made compulsory to have this as part of it, and we have to find the person who can have the knowledge of predicting it. Though in high-speed rail, the Japanese wanted so many instrumentation to be done in the piles, but we lack that knowledge here in-house. So we have to develop parallelly. We have to associate with institutes, and we have to see how we can do the structural health monitoring and other things. We can do it. Definitely is going to be there, order of the day, coming in maybe another 5-6 years. Yes, it is going to be a compulsion from the government side.
Okay, yeah, Dr. Sonia.
Okay, I fully endorse what Professor Premwarth just mentioned about manufacturing sector. So if you look at the sector, there are many issues which we see from my experience in ISRO point of view. primarily on the skill sets that are required here, specifically in terms of tooling design. There is acute shortage of people, acute shortage of people, and how do you really create capacity in this in terms of tooling design? For example, a manufacturing process requires a lot of tooling concepts. So training institutes which are there to help in building tooling design is one of the important issue which we are seeing. Second, of course, is what just mentioned about the underutilization of the capacity that if you create in advanced material is a serious issue. One of the issues that we faced in ISRO is that there are capacity, they're ready to do that, but the investment is very high. And if you put that investment in some plant and it produces the entire requirement in just 1 month, 11 months, there is no work for them. So none of the facilities or infrastructure which there in the country who are willing to put up that type of facility are not interested. We have problems in that in aluminum alloys. For example, the entire aluminum thin sheets which are required for space program is imported, whereas thicker are still made in India. We have no issue with alloying, making ingots, but converting them to sheets and high quality aerospace products is simply because investment lacking and not because there is no knowledge or skill. Unless we become an export oriented manufacturing, there is no sustenance of it.
That's a very important point. We have to be competitive with the rest of the world.
Yeah.
I can quote one example. I started my career in Mishra Dhatu Nigam. In the mid-80s, India was able to produce margin steel of international quality, but not cost competitive.
Correct.
And this is where we should have really focused so that we actually, and that was a time, I don't want to mention, one of our neighboring country was caught in US trying to smuggle margin steel out of US.
Anyway, marine steel is a good story that we can always be proud of, that we are able to alloy it and produce it in size. And we are consuming, we are not importing it now. But there again, another issue is, again, look at the carbon fiber. It's no question of capacity here. It's all capacity to produce high quality is still there. Nobody is putting the money up front to do this because the utility is so less in this country. We need to look at export market. This is another case of this. Similarly, there is yet another issue which is happening in terms of materials is about alloying elements. Though we talk about high strength alloys, the alloying elements which are required for it is coming from somewhere. Okay, so that we are fully dependent on it. There is no effort or rather a subsidized or government program to create that capacity in the industry. It's not happening. We are happy importing and the price variation is so high that ultimately the alloys are costing very, very high compared to what you are importing. So that is why everybody is happy importing because it is at a lower price than what you are able to produce here. Because the constituents are much higher cost than all the value addition, it doesn't add value. So that means it's not because that we do not have those alloys. We are not putting pilot plants or allowing those type of work to happen in the country to produce it at scale. Though labs are producing them, but not in scale. So I think one of the point I want to summarize is that there must be like what the chip manufacturing ecosystem now we are created by incentivizing. We need to incentivize it because unless government comes into some of these core areas to support and create as capacity, don't look at the profit or otherwise, because unless you have that ability, any time we can be chalked. I think this has been raised again and again and again with governments. I think there is no visibility that it is getting solved. I think we need to figure it out.
Any other question? Yeah, Dr. Mishra.
I think this is a very good, the deliberation is very good because about manufacturing. One of the, of course, it has been pointed out, I think one of the factors is that manufacturing, needs very heavy investment, and the paybacks, is only 15% at the best. So it takes a long time to get the money back. The fact is also that in the last 20 years, since the turn of the century, India has become what I call Indian education has become service-oriented education, and even the NEP has failed actually to recognize that, the national education policy. There is no product orientation in our curriculum. The whole curriculum in India is designed to be of superior quality, but to serve what purpose? A superior quality education, same standard as MIT or whatever it is, Caltech or whatever, is essential, but I think that cannot be the only focus because we are a large nation with a large population. And we need to make products ourselves. We need to create, as he said, Professor Premwat said, we need to learn design capability in our engineering colleges, which is totally lacking. There is no capability of engineers coming out of the BTech degree. Their design capability is not very good. We need to teach those capabilities into the engineer. We need to instill those engineering capabilities into our curriculum. Actually, we haven't done that. And what Professor Manna said also is very true. A graduate, he says, if I take IT, which is softer job actually, if you look at it in a long-term basis, I get double the salary of the man who is doing not only civil engineering, but even electrical engineering. Graduates today, they don't get jobs today at a competitive price. That can only change if manufacturing picks up. And the manufacturing sector makes more money or more profit or whatever, more revenue, to be able to pay them more, which is not happening. But I think they basically, it needs not only a change in the way we educate our BTech students. I think that's not happening. With NEP, that didn't happen. NEP focused on higher level of quality in education and maybe broader education, so that people. But I think some of the issue so that I foresee, because now I'm associated with the university, is that we don't teach the students to design. We don't encourage the student to build a prototype as a project. The emphasis on doing a project is simply to write a paper.
To strengthen your argument, Dr. Mishra, let me share a fact. If this country has 3,000 engineering colleges governed by the ICT, every one of them will have one department at least, that's computer science and engineering. No complaint about that. But not even 10 departments exist in the area of metallurgical engineering, in the private sector, not even there. So where will manufacturing happen? I mean, this shows the apathy or the lack of interest or policy drive in those areas. At this point, okay, I think we have hands raised here. Let us hear.
Thank you very much. You finish your sentence first.
Just 1 minute, Dr. Mishra.
Sir, I wish to make a very small point that in conceptualizing development, we have focused on technology rather than society. When we urbanized, we created slums along with them. When we improved irrigation, we caused depletion of groundwater, causing so much of it. We have water supply all over the country. Nowhere you can drink from the tap. So we have ROs and other things at our house.
But these are policy issues, right? I mean, this is where you're saying that.
But we are here also to influence policy issues.
No, obviously, I agree. I certainly agree. I mean, at this point, Shivaji wanted to raise a point. Let's be quick. We are running out of time. Yeah.
Thank you very much.
It's on. It's on. No?
Yeah, thank you very much. I am Shivaji Chakravarti from Jadavpur University, Electrical Engineering. I am having a slightly different opinion of what the discussion was going on. I was reading an article and there was an information there that in this world, if X number of people are working in design, 1 in 6 of them are working in India, designing something, but for somebody else. Now, that means that we can design. So, what is your opinion on that? Because this design concept you are saying that we have to design. So, we can design. Indians are design, but not for India, for somebody else.
Well, even those companies who are designing in foreign countries, you won't be surprised to see many of them actually are of Indian origin. But on the other hand, the hard fact is also the following, that Finland, with a population of 1/5 of the population of the city of Calcutta, is occupying the 7th global innovation index standing. We, India, today are now somewhere between 30 and 35. So that shows that we are not able to channelize the energy and talent that we have within the system. So before we, please.
Sir, we were talking about this manufacturing and the other. What I feel is because there is a large gap. Unless we make our local product, as he said, it's a global market. There is no survival for us. But we also can, because these are all little older sciences, which because the reason that quantum and because government is also taking initiative in the quantum as well as AI and ML, so that at least these are all little gaps or it's all developing, so that we can concentrate more on such areas so that we can catch up fast with those technologies. And in addition to that, parallelly we can concentrate on this manufacturing and making it global. That may be a better approach, I feel.
For technological self-reliance, there is no escape from the fact that you need both design or the virtual aspect and the real aspect. And the real aspect is the hardware. And the hardware has to have a huge backing from the manufacturing sector. Before we end, I feel obliged to share with the audience an experience which INA gathered in the last few years. Starting from none other than Rodam Narasimha, and over the years, through several presidents of the academy, INE made several pitches, at least a dozen representations to the government, including the Aviation Ministry, Science and Technology Ministry, that India should produce its own set of RTAs, regional transport aircrafts. And for that, we pleaded with the government saying that there is a government department which is sitting with 80 crore to create a detailed project report and take up a few trials, create a prototype and go up to a few trials. For at least 5-6 years, I myself was part of those delegations, number of occasions. But I mean, somehow we weren't able to impress with the government that we must make an effort, and no success is sustainable without failures. If we tend to believe that we make a plan, give a budget allocation, and very next year there will be all success stories around, that never happens. No country has ever reached to that level. So we need persistence, and also for technological development, it doesn't come out of the blue. If you have to really encourage innovation, then there has to be a lot of investment on research, not for only publication, research for ultimate technological development. The numerator remains the same, 0.64% of the GDP. The population has gone to over 1.4 billion. The numerator has enormously increased. So per capita, the amount of investment we are seeing for innovation is actually decreasing. Yes. So how can we expect that the country will really be very innovative and make a huge stride in terms of whether it's manufacturing or in any other sector for that matter? But yet, we have reasons to be proud with the achievements of what our ISRO has achieved, defense has achieved in the recent experience that we all are very proud of. India made a very strong statement before the rest of the world that India can develop its own missile of world plus. So the question remains that how innovative and how self-reliant we are on this. If it still depends on foreign design or even material supply from the foreign countries, then possibly we are not moving towards our goal of self-reliance. So what is also very encouraging is that we did express our concern that the country's economy depends so hopelessly on service sector, but we debated so much on manufacturing. I personally feel that was a very good indication that we all agree that the country really needs a lot of engineering solution, a lot of emphasis on hardcore engineering, and then only we can be someday a developed nation, Viksit Bharat. So with that hope, I would like to thank my panelists, very eminent panelists, Professor Premrat, Ms. Shravi and Mr. Sankalpit Nathan. I would also like to thank the audience for taking active interest and remaining glued and raising very pertinent points and giving us important comments and facts and figures. And this is how INE would like to serve the nation for the benefit of the engineering profession. So let's wish INE a very bright future ahead and end the session. Thank you very much.
Thank you, sir. May I now request Professor Indranil Manna to kindly felicitate the esteemed panelist of the panel discussion.
You are only ready to join the panel. Let me begin with you. Thank you very much. Mr. Brember, you generated so much heat on manufacturing, so thank you very much. Thank you very much. Our president is your senior colleague.
Yes, sir. One of our directors.
Right. Yeah, done. Thank you. That's good. Look for Mr. Brember.
It is my great privilege and a moment of immense honor to warmly welcome our esteemed chief guest, Dr. Ajay Chaudhary, to this distinguished gathering on the occasion of 40th Foundation Day of INAE. We are truly grateful for his gracious presence and for taking the time to be with us today. Dr. Ajay Chaudhary needs no introduction, but to inspire the young minds, here's his brief introduction. Dr. Chaudhary is a pioneering force in India's technology landscape and a co-founder of HCL. He led HCL's global expansion into Singapore and across China, Hong Kong, and later transformed HCL Infosystems into a market leader in hardware, systems integration, and mobile distribution. A key architect of India's electronic system, he has advised the government since 1999 and chaired a landmark 2009 task force under Ministry of Electronics and Information Technology that shaped the national electronic policy. He currently chairs the mission of governing board of the National Quantum Mission and is a distinguished fellow of Niti Aayog. Honored with Padma Bhushan, Dr. Chaudhary has received numerous accolades, including Lifetime Achievement Awards in the electronics and ICT sectors. Known as the father of Indian hardware, he championed self-reliance through initiatives like the EPIC Foundation. A committed philanthropist, he founded the Swayam Trust to promote education and women's empowerment, including the Aspire Scholarship for engineering students. He's also an active startup mentor and investor associated with Indian Angel Network and has backed over 70 ventures. Dr. Chaudhary holds a degree from Jabalpur Engineering College and has received multiple honorary doctorates. His memoir, Just Aspire, Notes on Technology, Entrepreneurship and Future, reflects his vision for India's technological future. As a symbol of appreciation and reverence, I request Professor Santanu Chaudhary, Vice President INAE, Dean and Professor, Vishani School of Advanced Computing, Ashoka University, former Director, IIT Jodhpur, and Professor IIT Delhi, to welcome our chief guest, Dr. Ajay Chaudhary, by presenting a bouquet. May I have a huge round of applause, please? Thank you. With great respect, I now invite our esteemed chief guest, Dr. Ajay Chowdhury, to share his thoughts and deliver the keynote address. Thank you, sir.
Good morning. I hope everybody can hear me at the back. Great. We are living in a very different world. And last 2 years, especially due to one person, the world has changed. And the world used to be a multipolar world. It seems to have become a unipolar world. Fundamentally, what that means is that every country is on its own. And one of the key areas that we now need to look at as a country is where do we go from here to where we want to be. And as Professor Manna was talking about it, we have focused completely till now on services. And this whole dependence on services is now under threat. And the threat is fundamentally because of AI and automation. The software exports area has really served us extremely well. And with $300 billion of revenue, that has been a great savior for the country in terms of foreign exchange. But that is, as I said, under threat today. We can see the layoffs taking place globally in software. India has escaped it till now, not too much, but globally you can see the changes taking place. Now, if we really want to be a developed nation, we need to look at where we are today. And where we stand today in terms of GDP per person is a low $2,600 per person. Now, when I looked at how the trajectory was for countries like Korea and Taiwan and China, one key point that comes through, again, is that they focused on products and we focused on services. 60% of our GDP is based on services, while China's GDP, 90% is based on products and commodities, only 10% on services. So this change that we need to bring for ourselves from 2,600 to 10,000 to 20,000 to 30,000 cannot just happen if we continue the way we are doing, just depending on services. So we need to move on to be a product nation. Till now, we've done good work in manufacturing, but we've still not been able to achieve the targets that were set up to achieve between 15 to 25% of our GDP in manufacturing. And a lot of the manufacturing that we are doing today is low value added. And our capability of design and engineering, we have not really utilized. And as a result, our value addition remains very low. So therefore, we have to move on from make in India to design and make in India. We have to design our own products, and we need to compete with the rest of the world when we design these products. We must not design them only for Indian requirements. We need to design them for the world. Now, as a result of what we are facing today, it's very critical to start to look at, in addition to design and manufacture in India, we need to look at our preparedness in the new environment. In this new environment, the whole issue is about owning technologies. And therefore, critical technologies, and mostly technologies that are used pretty much every day, we need to make it ourselves. We need to now own technologies rather than depend on global technologies. Clearly, we have seen the things that have happened in the last 1 year. Technology has been weaponized, and we have seen absolutely unreal stuff happening, okay, with the targeted surveillance and attacks that have taken place. Today's wars are digitized. Many years ago, intelligence chief in the Senate of US, Ben Sasse, made a very interesting statement. And that statement said, the next wars will be fought with semiconductors. What are we seeing today? Whether it's the use of communications in conflicts or the deployment of advanced artificial intelligence tools in strategic operations, technology is used for battlefield power. In Iran's case, surveillance systems reportedly tracked movements of vehicles through telecom towers and CCTV networks. So literally, technology has become a double-edged sword. It empowers, but it also exposes. The more dependent a country is on external systems, the greater is the vulnerability. Today, global digital monopolies dominate the landscape, wielding influence across borders. The United States controls software ecosystem, while China dominates hardware. Between these two poles, most countries, including India, remain dependent. Our digital backbone, including cloud infrastructure, search engines, social media platforms, semiconductors and servers, is largely controlled by foreign players. Apart from our success in building DPI, the digital public infrastructure, which is of course unique and is the only single large product that India has ever created, we own very little of the core technology stack. In a world where technology is increasingly used as a geopolitical tool, such dependence poses strategic risks. So today, economy and technology have got deeply connected. Today, till yesterday, economic power was considered the most important thing for any country. Today, economics is dependent on technology. From cloud services to messaging platforms, much of India's data resides with global vendors. On the hardware side, dependence on imports, particularly from China, remains significant. Although the manufacturing of phones has increased and our electronics manufacturing has increased, the imports from China also increased last year, more than $100 billion. This situation, we are fundamentally squeezed between the US and China. and the supply chains are also controlled by them. Well, the risks are quite real. In most of our critical products, we use Chinese chips. And Chinese chips can have backdoors, and they can send data back to China. And it's not that it's not happening, it's already happening. Recently, there was a case where CCTVs in India were used by Pakistan during a campaign that they recently did, and they took help from China to do that. Because pretty much all CCTVs in this country are Chinese and have Chinese chips. If you look at what happened to Huawei in the US, over a period of time, Huawei became so big that there was serious concern about them sending data back to China. And as a result, the US and Europe banned Huawei. They also banned CCTVs. We have not done so. If you look at recently, there was this joint venture with Russia in India, and there suddenly overnight, Microsoft switched off its services. And people next day didn't even have an email to send. And this kind of disruptions can happen anytime. Sanctions can happen anytime. India has fundamentally followed a very open approach. We have allowed all tech giants to happily participate in our economy. Nothing wrong with that. But with digital adoption, it has also increased dependence. The recent weaponization of platforms, for example, the United States decided that Russia will not be able to use SWIFT. And suddenly SWIFT was switched off. So this is something that is happening more and more. Digital infrastructure is the new battleground. Equally concerning to me is data colonization. When countries rely on foreign platforms for critical services, they risk losing control over their own data. Under certain legal frameworks, data stored on global cloud platforms may be accessible to foreign governments. The US law clearly states that any data on AWS or any of these services has to be made available to the United States government. And we are happily using such services in the country, including in the government. So basically, what are we looking at? We are looking at sovereignty and security together. Satellite systems, navigation platforms, and communication networks can then be controlled or disrupted. Reliance on external systems like GPS carries risks, as we could see during Operation Sindoor, where we did not rely on GPS and we used our own NAVIC. But even, as a matter of fact, today, NAVIC is non-operational. Okay, so we have a serious issue here where we do not have a GPS equivalent. As you could see in the recent wars, including Operation Sindoor, drones played a huge role. Now, these were used extensively by the US, Israel, Iran, Pakistan. India has made good progress in making its own drones, but a large number of drones that we make in this country do not use Indian products. They use Chinese components, and therefore they can be controlled. As a matter of fact, if you may recall, recently there was news that China hijacked electrical buses in a country in Latin America. Remotely, they controlled the buses. So this whole connected world today presents a completely different security risk and technology risk. The next area that I'd like to talk about is quantum technology. India has started to work very deeply in creating its own quantum capability in computing, in communications, and in sensing. Why are we doing that much ahead of time? The reason for it is very clear, that that's going to be the next frontier after AI. In a manner, we lost the AI bus. In a manner, we lost the semiconductor bus. So many buses we have lost. But this time, the government took the decision of starting the National Quantum Mission right on time. Despite that, we are still trailing in quantum computing. When we started the National Quantum Mission in January of 2024, we were sitting at 7 qubits quantum computer in India. And for those who may not know qubits, basically in case of classical computers, we use 0 or 1. In the case of quantum computers, we use 0 and 1, and these are called qubits. Now, what is the status today as far as quantum technology is concerned in India? Is that from 7 qubits, we've gone on to be 64 qubits this year. Our target is to achieve 1,000 qubits in 8 years. So it's still a long journey. In addition to that, but the good news is that in quantum communication, we are world class. We have recently demonstrated that we can secure a 1,000 kilometer fiber using domestic indigenous products called QKD, and this has demonstrated that we today have capability to actually protect our networks. And why is that so necessary? The reason why it's necessary is that Q-Day is approaching any time. And what is Q-Day? Q-Day is when a quantum computer will break our existing RSA cybersecurity. Now, till now, it was thought that it's about 10 years away. But recent advances in technology are clearly stating that it's not more than 3 to 5 years away. That means by 2029, 2030, we must protect the country's networks through quantum communication technology. And we must make ourselves quantum secure. So to enable that, in the National Quantum Mission, we set up a task force. And we have directed all organizations in the country to start to work on replacing RSA and integrating quantum communication, quantum secure communication. And this is essential if we do not want to see our financial systems going down one day. And the reason for it is that we should be very, very concerned that we have no idea what our neighbor is up to. China could have a quantum computer very, very powerful, which could crack our cybersecurity. But we do not ever know what is China doing. In Europe and US and other countries and in India, we know where we stand in terms of quantum computing capability. But in the case of China, we have little knowledge, and it's a very opaque system, and we have little knowledge of where they are. So suddenly overnight, in 28, 29, a Chinese quantum computer could bring down our complete financial systems and our electrical grids, which of course will be a complete disaster. So to prevent that, the country has to now secure itself in all critical areas like financial systems, like electrical grids, like telecom, like security and defense. That has to be priority 1. Priority 2 has to be other enterprises, because every enterprise's information and data will become insecure. But that we are talking about the future. Something else is happening in this area. It is called, the whole concept today is that a lot of data that is there can be picked up today and kept away and decrypted 3 years later. That means even today's data that you have is insecure. So this is something that is very, very critical and hence needs attention from us as a country. Now, technological self-reliance means moving beyond assembling imported components to designing and owning key technologies. And where is the problem? The problem today is that how many engineering schools in this country teach students how to make a product? It's all about theoretical knowledge. There is really hardly any institute in the country that is focusing on teaching how to make a product. And unless we changed our curriculum and we change the way we teach engineering in this country, we are not utilizing our brains. We are not utilizing our design capability, which exists in huge numbers. How have we succeeded in software? It is because of our brain power. But here in the country, we are not using it. And therefore, engineering curriculum needs a huge change. Literally every engineering institute has to have a product design and product making capability. And students need to be taught design to manufacturing. This is something completely missing. It's only a few institutes that have taken it up on outside the curriculum, but within the curriculum, it doesn't exist. So, I think I want to tell you what the other countries have done to protect themselves. China learned this lesson long ago, that they need to protect. And therefore, they created something called a Chinese firewall. That ensured that the data of Chinese citizens and businesses remains in China, accessed only by Chinese companies. For example, China does not use any of the American cloud services. They are not allowed to use. Now, the other thing that China did was that they themselves used to steal data and steal information. What they did, knowing that very well, in every government office, they do not allow any other product than a Chinese product. Whether you use a PC or you use a tablet or you use a phone or you use a networking equipment, it has to be Chinese. So look at the way they have protected the country. Now, if you see in 2022, France renamed its finance ministry. Now, this is very interesting. They renamed their finance ministry as Ministry of Economics, Finance, and Industrial and Digital Sovereignty. So you can see the importance countries are giving to sovereignty, technology sovereignty, digital sovereignty. All IT products in government now have to be French. Germany has replaced Windows with Linux in government offices. So these kind of changes have happened. We are still trying to find a way for us. A while ago, some of the government departments decided to use Zoho and start to use a local email system. But the percolation of this has not happened all over the country. It has probably happened in some central government offices, but that's not the country. Each state has to do this, and they have not done it. So I think this battleground shifts from land and resources to data, algorithms, digital infrastructure. India cannot afford to be a passive participant in this transformation. It must act decisively to secure its technological future. In a world where technology is increasingly weaponized, sovereignty is not just about borders. It is about control over systems that power the nation. So I think we are sitting at a serious inflection point. We know what our challenges are, but we cannot afford to shove it under the carpet. We now need to take action very quickly. And I think this is really where all of us can play a role in convincing the government to actually start taking a clear decision on becoming technologically sovereign. We have so many areas to work on. The task is big, but if we do not start now, I think we would have lost the battle. And we know that China used Pakistan as a proxy to test all its weapons and used drones which could be controlled. So recently we did an exercise with the defense, and we proposed from the National Quantum Mission that how can we make sure that the drones cannot be hijacked? Because the challenge is that any drone can be hijacked. So what we have done is that we have put a quantum secure chip in drones, and we recently tested it, and we found that this was extremely valuable, and this is the kind of action we need to take in literally every product. And just the communication links all over the country are not what we have to secure. We have to secure the edge products also. We have to secure our PCs, we have to secure our tablets, we have to secure our phones. Today, defense forces use open communication on phones for all their work. Only in certain areas they're using a specialized phone. But generally, all government offices, defense, everybody uses a normal phone. It is open to serious issues in terms of security. So I think I just wanted to today point out that not only do we need to work on becoming technologically sovereign, we also need to go deeper into our curriculum and teach our students to move from just services to products, as well as help them make products, design products. There have been, some universities and institutions where they've got tinkering labs. But we need to take the tinkering labs to actually being part of the curriculum. Unless that is done, we are not preparing our students for what is required. We prepared our students for software very, very well. But have we preparing our students for making and designing products? I think That is a huge change we need to bring around. I still remember that 10, 15 years ago, anybody you knew who knew C++ would go to the US. That is history. Today, all that knowledge is of no use because AI has stepped in and those kind of capability have nothing to do with us. So I think I don't want to belabor the point, but the point is that we must use our brain power to design and make in India and move up the chain, value chain, go on from $2,600 per person GDP to 10,000 to 20,000 and 30,000 rather than stay as a middle income country. And that is something that we can do while securing ourselves. Thank you.
Can we have one or two questions? Sure. Yeah. Any questions from the audience?
Good afternoon, sir. I'm Colonel Rohit Gogna, sir. I'm founder and CEO of Sanrachna Prairie Private Limited. We are a company incubated in IIT Delhi, and we are into structural health monitoring. So firstly, sir, compliments. I think the clarity of thought was immense, and as a founder myself, I get a lot of direction from what I heard from you. So my question is, actually it's a triad question. It's more for, agencies where, let's say, the government, industry, and the academy are coming together. I want to understand what is the support. What is the support system that a startup like us can expect, from this triad? I know what the government is doing, so there is, financial support. But what about the industry? So little insight into that.
Well, actually, the link between industry and academia is pretty much broken. But good news is that some of the institutions have taken a very strong position in involving the industry today. Like, for example, IIT Delhi, deep involvement of industry. I see that in IIT Madras. I see that in a lot of IITs and institutions. So the industry is coming in, but is the industry coming in to work together with startups? No. So it is still not there, but good thing is that some industries have now set up their own incubation centers. And these incubation centers are meant to help startups to create solutions and products. So it's still very early days, but it's starting to happen.
Thank you. So one quick follow-up, because the academia, you are absolutely right, designed to build, you take on that in the future, and I find that some of the lower level engineering colleges are probably doing better than the top tier ones on that account. But in the industry, I've noticed one thing, sir, with 1 year into this new thing that has shifted from the armed forces to the entrepreneurship, is that a lot of industry, in the name of supporting, is actually, trying to get ideas to evolve something internally. I've had this discussion with many bigwigs in the industry that instead of supporting, you are rather, kind of like getting into a thing of building it in-house and not really supporting in the real sense. So, sir, I think this is a right forum where a lot of bigwigs are present. I think the industry in India has to take account of what they need to do with this triad becoming actually a quad with the startups getting their due relevance, is I think something which needs to be taken into account.
I am very clear about one thing. Innovation fundamentally happens in small companies. Innovation is part of entrepreneurship. So the kind of innovation that will happen in startups will not happen in large organizations, because they are so bound by what they are trying to do that they don't want to change. So I think if you look at the industry in the last so many years, what have they been doing? Large companies, they have gone to China, they've picked up a product, put a logo on it, and sell it in India. We have become a trading country. And as a result of that, we are at very low margin work that we do. Value addition is 5%, 7%, 10%. We may be making the largest amount of Apple phones in the world. But what is the value addition? So I think this is really where the change has to occur. And I think some of the actions taken by the government recently into focusing on creating a component ecosystem in the country will be very valuable. But the industry, I agree, is still not open to creating and working together with startups. It's something that, you know, we all need to work on making it happen. Okay?
Okay, I think Indranil, we had a question.
Dr. Chaudhary, it's more of a request and a comment. The request is, you know, everything that you touched upon, I couldn't find a single item where we don't agree. We agree on all the recipes that you kind of presented before us. So would it be possible for you to look at your notes and then give us certain bullet points, and then we'll make a team to work with you to come up with a white paper, not necessarily a thesis, but just a short white paper, which from the academy we would like to share with the community, with the profession, that there could be many more beyond what you said or beyond what we can think of. But some of these, starting from cybersecurity to lack of ability of hardware manufacturing, to the way China actually made itself self-reliant and so on. We have been hearing a lot of slogans, maybe with good intention, but it's time we actually translate them into real, actions. The comment is about another thing. You mentioned about tinkering labs and so on. You know, in Kanpur, we were so passionate about it and created with alumni funding, and similar infrastructure exists in, initiatives exist in other institutions. But let's also not forget that we have capacity, if not actual numbers, of 1 million graduate engineer a year. Not even 10% of them go and see an industry before they get a 4-year degree, BTech degree. It's like you are rolling out MBBS who have not touched a single patient. So we want to make engineers, and the engineers don't get internship in any industry at all before they actually, majority of them end up doing another research project in the same department or another department. Nothing wrong in doing research. But the point is, and we have reasons to be proud that we are the 3rd largest publishing nation in the entire world. But what you said is very right, that unless you actually experience what it takes to manufacture or create something, how are you going to call yourself an engineer? So some deep thinking is needed. I mean, I personally feel is very, very important. Thank you.
That's a very good idea. I'll definitely send you some of my thoughts and you can create a white paper around that with lot more detailing. And that needs to be widely circulated among the community so that we start to actually take actions on this. So you may want to, in the white paper, put out the actions so that they can be taken. And I would like to mention that my thoughts are not just restricted to myself. I have actually been talking about it with different ministries also. So Ministry of Electronics is somewhere where we have actually discussed this whole thing. And they're currently talking about creating our own operating systems, our own, databases, our own email systems. This discussion has started. The similar discussion has been done with defense, and they are also starting to look at what we need to do. For example, today, defense very clearly states that they will not accept a drone product if any component is made from China. So these kind of changes are happening, but I think we need to do it widespread. We need to, in every area, we need to think like what China did. If you look at what China did, they created equivalents of everything. So we need to have an AWS equivalent in this country, right, because we are losing data. And this is something that we are not able to action. But some of this work, I have done with my colleagues and we have started to talk about it. But I think it needs much wider acceptance. And is not just acceptance, is the urgency of acting on it. The urgency is something which is you may want to bring out, because we can't sit back and say, we'll take 5 years to do this. No, we don't have that 5 years. So I think that's really where we need to act.
I think we are at the juncture where we have to act immediately. And I think this kind of the white paper can actually initiate that move. I think Sanjay has a question and then I shall come back.
Yeah, thank you, sir, for a very inspiring lecture. You mentioned about product development, and I think the way the conventional engineering colleges are set up, there are these majors that we give out, then there are minors, and then we try to give a product development within the majors. But I think if you look at a typical engineering graduate, those who succeed into making products, more often than not, they make products which are beyond what they were trained in because of certain circumstances. So do you think the time has come where we remove these boundaries of majors, at least in the engineering education, and in fact they should become minors, and the focus should be on products? And so if I am an aerospace engineer, I really don't graduate as an aerospace engineer. I have a specialization which is engineering, and I am trained into making a product, and maybe I can get a few minors along the way. What do you think of this idea?
It's a pretty interesting idea. The key thing is to convince AICTE and other regulators that that's what we need to do. They are not easy to convince. But I think the IIT system can do that and can innovate and create that. I was involved with creating IIT Hyderabad. And there we created a concept of minors and majors. And there we had a concept where we wanted to make a student completely have a holistic approach to engineering and other areas. So we created a model where there were 36 minors that were available to every student. And they had to choose 4 or 6 of those. And they were not necessarily engineering.
In fact, IIT Hyderabad had that engineering science BTech. I think following that program, we also started something at IIT Jodhpur also in that direction. So
My name is Sanak Mishra. I have when I have discussed with political masters, the issue that comes up in their mind, I find, is security versus prosperity. So, they don't know where the balance is actually. So the growth of the service sector in India in the last 30 years primarily used existing infrastructure that was there in the country, And I think that's coming to a saturation now because we are not developing our basic infrastructure rapid enough. But my question was that the reason we went to, imported products and imported software and all that, because they were cheaper and they did actually raise the level of prosperity of the average Indian. Now, your thesis is that the time has come that we need to look at the security, in a far more serious manner than looking at, if I may put it like that, just for the sake of figure of speech, that looking at the prosperity, how far we can be prosperous. If you take the Chinese, what they did is they actually remained poor for a very long time from their independence in 1949 to till about 1990. They remained very poor by design so that they focused on their internal strength rather than national prosperity. Would you like to comment on this, what I said? Prosperity and security, how do you have a balance? Because political masters are always, saying that we need to give more prosperity to the people. So we will import from China, we'll import from wherever it is cheaper, even though there is a security risk.
Well, we are still sitting at $2,600. So where is the prosperity?
Well, you see
what have we achieved till now in last 75 odd years? We are still sitting at $2,600. So I would question the discussion that prosperity is not what they have looked at. What they have not looked at is security. And I think the other thing they have missed out is not just security, is the sovereignty part of it. We have to be very clear that economics and technology are deeply connected today. If you look at 15 years ago, that was not the case.
Yeah, yeah.
Why is the US so powerful? Because of its technology.
Yeah.
Why is China so powerful? Because of its technology. They are using technology as weapons, which we have not realized. And it suddenly hit us today that that's what we need to do. And we need to change the way we think.
Yeah.
You see, this whole thing about prosperity is not, to my mind, any issue.
Right.
The real issue is the issue that where we need to urgently today start to look at making this big change. And the change has to occur from curriculum to the government.
Right. So the other point was that, you know, the hypothesis that we need to be a product nation. I mean, I'm a strong advocate of that. But the how far you think, you also made a comment that, you know, we are good at trading, so we have been trading, right? But how do we move from a hypothetically trading nation to a product nation? Do you think the government policy today, as it is taking us in that direction? Or what needs to be done more?
Good news is that a major announcement took place from the government last year, which was to set up an R&D fund of 1 lakh crore. And in that 1 lakh crore R&D fund, which has been created, it's for 50 years with no interest. So this R&D fund has been created to fund R&D in private sector. For the last so many years, we have funded only government research institutes.
Absolutely.
We have not funded the private sector. Startups have happened and taken the lead on their own in terms of R&D and design and development. But the R part of it is not really there. It's mainly development. Now, if we want to look at where we want to go, this RDI fund is going to be a major game changer. And I think the implementation has already started. And this is what is going to make changes in the country. You see what used to happen in the US. When DARPA, many years ago when it was set up, its whole strategy was to develop private sector. So what did they do? They would take a challenge and say, here, there is a product that we want you to make. If you make this product, we will buy a lot of this product from you. And so what they did was they were able to scale up the businesses by giving government business. It does not happen in India. In India, all kinds of tenders will be put out to support foreign products. This whole thinking needs to change. We need to value our own products also. You go to Japan, if you ask them, they will only buy Japanese products. That kind of nationalism in this country doesn't exist, whether it is in the government or in the general public. Everybody wants to buy foreign products. Now, if we continue this way, how long can we survive? Today, our imports, many years ago, I wrote a note for the government where I said, one day, the electronics import bill in India will be higher than the oil bill. It's happening.
Thank you. Thank you.
I think, thank you. We had a very illuminating talk and the discussions. I think this discussion can continue further after this event during lunch as well. I think let us thank Dr. Chaudhary for his nice talk and illuminating us with the issues and challenges the country today is facing, mostly from engineering perspective in terms of the national growth and our security. Thank you, sir.
Thank you, Dr. Chaudhary, for that truly inspiring and insightful keynote address. Your words have given us much to reflect upon and will certainly guide us in our future endeavors. May I now request Professor Shantanu Chaudhary to kindly felicitate our esteemed chief guest, Dr. Ajay Chaudhary.
Let's
So may I request you to please be seated as we will proceed to the next segment of the day. Please, sir. Distinguished guests, ladies and gentlemen, we now move to a very special segment of today's program, the felicitation ceremony of the founding and senior fellows of INAE. This moment is dedicated to honoring those visionary leaders whose wisdom, commitment, and pioneering contributions have shaped the journey of Indian National Academy of Engineering. Their tireless efforts have not only strengthened the engineering profession in India, but have also inspired generations of engineers and technologists. Today, we expressed our deepest gratitude to these eminent fellows for their invaluable service, guidance, and enduring legacy. May I invite these visionary leaders who grace us with their presence today, Mr. Paritosh C. Tyagi, Consultant in Environmental Management and formerly Chairman, Central Pollution Control Board, New Delhi. Professor S.C. Datta Roy, formerly Professor of Electrical Engineering, IIT Delhi, and Professor Prem Krishna, formerly Professor and Head of Civil Engineering Department, IIT Roorkee, to kindly join us on the stage, please. May we have a huge round of applause. May I also request Professor Shivaji Chakravarti, Vice President INAE, to please join us on the stage and read out the citation of these visionary leaders.
No, sir. Perfect, sir.
So welcome to this very special session. So first I read out the citation for Professor Prem Krishna. It is with great regard and respect that on behalf of INAE, I am privileged to present a brief profile of an eminent academician and stalwart, Professor Prem Krishna, formerly Professor and Head of Civil Engineering Department, IIT Roorkee, who was elected to INAE Fellowship in the year 1987, the year in which INAE was founded. He is affiliated to Engineering Section 1, Civil Engineering. He has made significant contributions in the areas of structural engineering, wind engineering, and long span structure. He is founder president of Indian Society of Wind Engineering and former president IAWE, and was conferred the International Association for Wind Engineering Presidential Award for contributions to wind engineering, particularly in low-rise structures, development and leadership. He obtained his BE Civil degree from University of Roorkee in 1959 and ME Structures in 1961 and PhD from Imperial College London in 1964. After which he joined University of Roorkee as a faculty. Professor Prem Krishna served as Vice President of INAE during 2008 to 2013 and was member of Sectional Committee 1, Civil Engineering, for 3 terms. During his tenure as chairman of the INAE Forum on Civil Infrastructure, Reports on Housing in India, Challenges and Way Forward, and Urban Transportation, Challenges and Way Forward were brought out. He was co-author of the INAE Research Study Report on Assessment of Civil Engineering Inputs for Infrastructure Development and co-editor of INAE 2037 Vision, Mission and Values document. Professor Prem Krishna was chairman task force for the compendium on landmark achievements in engineering and technology in independent India, compiled by INAE as part of the Azadi Ka Amrit Mahotsav celebrations, released at national level by Dr. Jitendra Singh, Honorable Minister of State Independent Charge for the Ministry of Science and Technology and Earth Sciences during the National Science Day function in 2023. He also authored an article in the INAE Mind of an Engineer Volume 2 book reflecting his personal experiences that made him an accomplished academician and researcher. He played a key role in the first INAE Technology Conclave 2025 at IIT Bombay on the theme Sustainability of Civil Infrastructure in India. Professor Prem Krishna has been honored with several prestigious accolades, the most recent being the Lifetime Achievement Award from IIT Roorkee Alumni Association in 2026 and the Lifetime Achievement Award 2025 by the Indian Concrete Institute. He was elected as an honorary fellow of the Indian Association of Structural Engineering and conferred the IIT Roorkee Distinguished Alumnus Award in 2012. Professor Prem Krishna, apart from his distinctions is respected for his gentle demeanor, reliability, and a positive team-oriented attitude that makes collaboration seem effortless and delightful to work with him. On behalf of Mr. J.D. Patil, President, Indian National Academy of Engineering, I have great pleasure in felicitating Professor Prem Krishna for his outstanding engineering achievements as a dedicated teacher and researcher and his exemplary contributions, thereby enriching the technical activities and programs of INAE. We wish him good health and cheer always. Let's give a big hand to Professor Prem Krishna. It is with great regard and respect that on behalf of INAE, I am privileged to present a brief profile of an eminent stalwart in engineering, Professor S.C. Dattaray. Formerly Professor of Electrical Engineering, IIT Delhi, who was elected to INAE Fellowship in the year 1987, the year in which INAE was founded. He is affiliated to Engineering Section 6, Electronics and Communication Engineering. Professor Dattaray obtained his MSc Tech degree in Radio Physics and Electronics from University of Calcutta in 1959 and his DPhil degree also from University of Calcutta in 1965. His teaching and research experience include teaching at the University of Colgany, University of Minnesota, USA, Iowa State University, USA, and University of Leeds, UK, and a long spell of over 4 decades at IIT Delhi. He is renowned for the excellent quality of his research publications in high-impact, peer-reviewed journals and for his superb guidance of doctoral students for their PhD degrees. His research have been recognized by several national awards, including the Shanti Swarup Bhatnagar Prize, and through fellowship of the IEEE and of all the National Academies of Science and Engineering, and distinguished fellowship of IETE. Professor Datta Rai was also conferred the INAE Professor S.N. Mitra Memorial Award during the year 2017 for his seminal research contributions in the field of circuit systems and signal processing. He also authored an article in the INAE Mind of an Engineer book reflecting personal experiences and career paths of INAE fellows that have made them reach the pinnacles of success in the engineering domain. Professor Datta Rai has made sustained and deep contributions to INAE in various capacities as Honorary Secretary during the period May to August 1995 and editor of publications from 1987 to 1989 and again 1991 to 1995. He also served as member of Sectional Committee 6 for 3 terms. Professor Datta Rai, apart from being a teacher and researcher par excellence, truly values most the love, affection and appreciation of a very large number of students whom he interacted with personally, an equally large number of his virtual students spread throughout the world through the video courses he authored, which are available on the YouTube. He has versatile and multifaceted interests and enjoys listening to classical music and researching on its history and the history makers, no less than the enjoyment he derives out of his professional work. Professor Datta Rai is much loved by his former students who remember him not only for the depth of knowledge that he imparted, but for his humane approach and mentorship. On behalf of Mr. J.D. Patil, President, Indian National Academy of Engineering, I have great pleasure in felicitating Professor S.C. Datta Rai for his outstanding engineering achievements as a dedicated teacher and researcher and his exemplary contributions thereby enriching the technical activities and programs of INAE. We wish Professor Datta Rai good health and cheer always. Let us give a big hand to Professor S.C. Datta Rai. It is with great regard and respect that on behalf of INAE, I am privileged to present a brief profile of an eminent stalwart in engineering, Mr. Paritosh C. Tyagi, consultant in environmental management and formerly chairman, Central Pollution Control Board, New Delhi, who was elected to INAE Fellowship in the year 1987, the year in which INAE was founded. He is affiliated to Engineering Section 10, that is interdisciplinary and special engineering fields and leadership in academia, R&D and industry. Mr. Tyagi obtained his BE degree in civil engineering from IIT Roorkee in 1953, ME Public Health Engineering from All India Institute of Hygiene and Public Health during the year 1960, and also has an LLB degree. He is a renowned expert in the field of environmental management and is an advisor for integrating environmental concerns in project formulation, implementation and operation. Mr. Tyagi is a strong advocate of engineers' moral responsibility, which is the collective and individual commitment by engineers to ethics, service to society and quality of life through forethought, research, planning, and design, incorporating care in all their contributions. He believes that only engineers have the ability to clear the present environmental mess largely created by them. Therefore, it is engineers' moral responsibility to take such action which will revive environmental quality. He also authored an article on engineers' moral responsibility in the INAE Mind of an Engineer Volume 2 book, reflecting personal experiences of INAE fellows in their professional journeys. Mr. Paritosh Tyagi was dedicated to the cause of INAE and was actively contributing to the technical activities, meetings, and programs of the Academy. He served in the INAE Governing Council during 1991-1993 and was member of Sectional Committee 10 for 6 terms. Mr. Tyagi is also a keen contributor in INAE seminars, workshops, and conferences and annual convention. He is a prolific writer and has authored a book on Pollution Control Acts and Rules with Amendments, published in 1989. He has also published pertinent research papers in the areas of industrial wastewater pollution control and other vital areas in environmental management. Mr. Tyagi was conferred several prestigious awards, including the Vajvik Award in Environmental Sciences and Technology in 2006 for his seminal contributions to the development of the sustainable framework and its implementation through a variety of state and central government agencies and NGOs. As a person, Mr. Paritosh Tyagi is well appreciated for his congenial personality, and he always has a pleasant word for persons of all ages and walks of life. On behalf of Mr. J.D. Patil, President, Indian National Academy of Engineering, I have great pleasure in felicitating Mr. Paritosh C. Tyagi for his outstanding engineering achievements as an expert in environmental management and his exemplary contributions thereby enriching the technical activities and programs of INAE. We wish him good health and cheer always. Let us give a big hand to Mr. Tyagi.
On behalf of Indian National Academy of Engineering, I extend a heartfelt gratitude to our esteemed fellows for their extraordinary contributions and lifelong dedication to engineering profession. We are deeply honored by your presence and truly grateful for your continued guidance and inspiration. Thank you. Ladies and gentlemen, we shall now proceed for a group photograph with the chief guest.
On stage, sir. Yes.
We request all the esteemed dignitaries.
Kindly come with the dignitaries here. A group photograph with 5 of them, or 3 of them, please, all 5. Then we'll request our leadership also. Please come, sir. We'll just push it back. Please come. Aye, sir. आप छोड़ दीजिए, sir. Will be taken care. आप आइए, please. आइए. Please. आइए, sir. हाँ, अभी कर रहे हैं. आइए, sir. पीछे. आप छोड़ दीजिए, sir.
Now we request our former presidents and vice presidents to kindly come on the stage for the group photograph.
Group
We request all the fellows to please kindly come on the stage.
Cannot be. I think. Can I suggest something? Outside you can go down and just take the picture from here. Sure, sir. Yeah, that's the best. Yeah. You can sit down. Just go down. Just sit down and.
Maybe some of you just stay on the stage and raise the first one. बाहर फायर में कोई जगह है बहुत अच्छे हैं बाहर एग्जैक्टली दैट्स
Ladies and gentlemen, I'm extremely grateful to Dr. Ajay Chaudhary, our chief guest for today, our former presidents, our eminent vice presidents and fellows for being here, and lovely students who have attended this function. We'll request you to kindly join us for a photograph outside. Immediately after that, we move for lunch, which is organized like a semicircle. We have to pivot our way down. Thank you very much for being here. Thank you.
Give it to me. Yeah. No. Pressure Dr. Rais. Give me pressure Dr. Rais thing. Yes. And then bring it down. Give it down. I'll look at it.